Welcome everyone. Welcome to an all-new Process Mining Café. Today I'm here with our good friend Xixi Lu. Xixi, welcome to the Process Mining Café.
Thank you, Anna. Very nice to be here.
We're really happy to have you here, Xixi. You're a tenured assistant professor at the Process Science group of Outliers at Utrecht University, and one of your research topics, so you're a core process mining researcher for many years already, but one of the topics you're working on is data preprocessing.
Yes.
So that's what we're going to talk about today. It's a very important topic, and also from our experience, we see that a lot of the practical questions that we deal with when we apply process mining have to do with data preprocessing. And Xixi has created a categorization, a grouping, an assessment of these types of tasks, and we want to align that a little bit with what we see in practice and compare it and put it next to each other and see where we arrive based on that. A quick note of housekeeping: we are not having a chat today, so there's still some technical problems with the platform we have been using. Instead, what you can do is you can send an email to cafe@fluxicon.com and mention your questions and feedback to that email, and then we address and respond to that at the beginning of next month's cafe. So that's cafe@fluxicon.com. Now, Xixi, maybe to get started with the topic, I'm curious, what interested you in the topic of data preprocessing?
Yes. First of all, thank you, Anna, for inviting me. Very happy to be here. Very happy to share. I have to say that I started interested in this topic actually during my PhD. We did a case study with one of the hospitals. At first, we couldn't discover the normative process. Nevertheless, after a few pre-processing steps, we were able to discover a very clean, structured process, very similar to the normative process described by the medical expert. So we were actually then managed also to perform more useful analysis like compliance checking, performance analysis. So from that experience, I really started into looking this topic and noticing also the importance of this topic. The more I look into this topic, the more important I find this topic, of course. And for example, one story I always tell my student is that there was a survey conducted by one of the data enriching platforms. So they surveyed about 80 data scientists, and the results show that those data scientists spend 80% of the time on data collecting, cleaning, pre-processing, and only 20% of their time are spent on actually performing the analysis and the rest.
Yeah.
So 80% are spent on data cleaning and pre-processing. So that's why I think this topic, we should actually know a bit better about it.
Yes, that's a good point. So this is a statistic that people sometimes cite, especially with the knowledge of data science. There's so much work in the data, and we have already also sometimes talked about how to get the data, getting the data out of the system. So that's kind of the data collection. That's in a different topic. That's also can be challenging, but it's about what comes after that. And so that's the phase before the analysis, before you do the analysis. That's where the pre-processing lies.
Yes. So the data pre-processing focus also. So the task we reported in our paper is really focusing on the advanced tasks. For example, integration, for example, enrichment. And the purpose of data pre-processing is also broader than just data cleaning. So it offers more possibilities and more ways we change or transform our event logs or event data into. And it can change how we look at the data, how we use the data. And so it's more than just fixing, for example, data quality issues. You can transform the data such that you can change from perspective to another perspective how you look at the data. and it could enable additional analysis or help get much more value from your data.
Yes. So it's separate from data quality, but is data quality part of it, or is it is there some overlap? How do you see the relation, and why should there be a separate category for pre-processing next to data quality?
So from the data mining field, data cleaning, so fixing data quality issues is a subtask of data pre-processing.
Okay.
In our paper, we decided to separate those two to focus on other data pre-processing tasks that are less reported. There has been a lot of studies on fixing data quality issues in our field. For example, there's log imperfect patterns by Sriadi from the QUT. There's data quality issues by News. So all those have been well studied, and we are currently focusing on other pre-processing steps which have been reported, not just solving the data quality issue, but indeed also, for example, enriching the log, enabling additional analysis and additional value that brings with it.
Yes. Oh, okay. That makes sense. So, yeah. So you could see it as the big umbrella term, but in fact, because of the lack of attention so far, which was the attention was mostly on data quality, you're specifically focusing on these other data pre-processing tasks.
Yes.
Yes. And we did. So we brought a few slides to show some examples, because what we wanted to do today is to go through these 6 categories. So I put them here. So there's 6 categories. They're all, it's nice, by the way, it's like log filtering, log enriching. And I think the paper that you wrote with Vinicius, you say like turning log into lumber, right? So it's really about slicing the logs in the right way to do good things with them.
Iris, our colleague, came up with that amazing name. Yes, she's very creative.
I believe that. Yes. Yes. So these are the 6 categories that you created. How did you come up with these 6 categories and not 3 or 7 or others?
Yes. So we first came up with this by also building on our past knowledge about high-level tasks. So before we dive into the sub-level tasks, we already built quite some studies around it. So from, for example, the process mining project methodology, the PM square, there in the data pre-processing, we already identify 4 high-level tasks. For example, the log filtering, log abstraction, log enrichment were already been mentioned there. Also, Dirk Vagland published a paper on the basic operations such as log aggregation, selection, projection. And Bos van Zelst and his co-authors proposed, for example, a taxonomy focusing on event abstraction. So based on this, a lot of existing studies who have focused on bigger pre-processing tasks in process mining, we have built our initial high-level tasks. And we can zoom into the discussion later, but we also separated filtering from reduction because we thought filtering is such a big pre-processing task topic here. And therefore, we put it really separately as a pre-processing task.
Okay, so initially this was one category and you pulled it apart.
Yes, so it could be both my focusing on the reducing the data, but because the filtering also had a much more focus on just cleaning or transforming log in such a way that it become a good format for the analysis. So we put out this filtering.
Yeah. Okay. So yeah, we'll come back to that, because what we wanted to do is really to go through these 6 categories, and for each of them look at what is the definition that you see for that, and to put that next to some examples maybe we can think of together or that we have seen in practice, and just to see how it lines up. So should we start with that?
Yes.
Okay. So we are not taking exactly the same order, like how they came up, but we are going to start with enriching. So, Xixi, what does the enriching category say?
Yes, log enriching means that the event log itself might have already contained a lot of information, and by making operation, for example, creating calculations, you can derive additional attributes just based on the information in the log itself, and we call that enriching.
Okay, so if I understand you correctly, you are creating, for example, additional columns in the data set. So you are creating something new, but you are creating it completely, entirely out of the existing data set by deriving this information from the data set itself.
Yes, so you're creating a new column, a new attribute, a new information data element by making calculations or deriving from the log itself.
Yeah. Do you have an example for what you would see there?
We have, for example, you could say you have let me think about it. I'm sorry. So actually, Anna created an example.
Yeah, I can show our example first. Yeah, I can do that. Because when you said enriching and taking it out of the data, extracting this information out of the data, I immediately had to think about the unfolding examples that we have. And there's two versions: unfolding cases and unfolding repetitions. And I put on the slides here to show you, to explain what I mean by that. So if you can see my slide here, that's an example which is relatively simple because there are just four activities. Activities are pick up, return, ready for pickup, and intervention. And it's basically a tool rental cycle. So some of the tools that you might need, for example, for some construction in your house or something, are very specialized, expensive tools, and you only need them for one day. So it doesn't make sense to buy this tool. So you can rent it just for the day and then return it. And so the case ID here is the tool. Yeah, the identity of the object, of the tool, but it's going in circles, of course, right? So they are very long cases. Basically, the lifetime of one of these tools goes through kind of a lot of these rental cycles. Now, for certain types of analysis, it's not really useful. For example, if you want to answer how long does it take, normally one rental cycle, you can't really answer that based on this information. So, and now comes the enriching. So we come back to the enriching part. Basically, we're looking at repetitions of certain activities when you are entering a new cycle, and you can use different activities for that. So, for example, if the pickup activity is the one, that's column C, but there's also other points depending on where you want to start the cycle. So. And then you can see that each iteration gets a new number. So basically, this number would be derived from the data itself, from the process. So this would be an example for enriching, right, Xixi?
Yes. So adding by calculating the multiple iterations, then you are adding information or deriving information from the log itself.
Yes, so you're adding those sequence numbers. So these additional columns, C, D, E, are enriched, are enriching the data. And then just to show briefly what you can then do by that, right? Why are we doing this? Well, during the import, you can then include this column in the case ID configuration, which means that they are going to be concatenated, combined together. And then you get a separate case for each iteration for the same tool, right? So and then the process map looks different because now you have many more cases, because one case is one rental cycle for one tool. So that's one example. And you can do a similar thing. We will put all these things that we are mentioning, the papers that Xixi mentioned, but also the examples that we are showing here, we will put them in the show notes together with the recording so you can look at it in detail. But you can do a similar thing with activity repetitions. Like here, if you have a cycle in the process map, which is what you usually want to see, but you might, for a deeper analysis of the actual repetition behavior, you might want to unfold this loop, and you can do that also by adding sequence numbers for each of the loops to the data. So that's also in a very similar way in an enriching, and then use that information in the import step, in this case on the activity name, so that the activities are unfolded for those repeating activities that you want to see. And then, you get a different process map with all that. But yes. Any other examples that you can think of for enriching?
I think a very typical example will be actually calculating the throughput time of the cases and enriching the cases with that throughput time as case attribute. And it could be then exported to do other analysis, for example.
But isn't that analysis? I would say that's something that you do in Disco, for example. I'm immediately thinking like that's something you do in Disco. Why would you want to put the case duration as an attribute?
So we have Disco has a very nice tool support, and therefore you can already automatically derive those as information and integrate it as a feature filtering. For example, you can filter already based on the performance. In other tools, I will not mention which one, this might not be available. For example, if you're performing analysis using Python alone, the throughput time attribute doesn't exist in the data frame. Mm-hmm. Therefore, if you want to, for example, use that as an input feature or use for other analysis, for filtering, for grouping the cases, that feature has first to be derived, enriching the log with that feature, and then use it for further steps in your analysis. For example, filtering, for example, grouping, or clustering the cases.
Yeah, that makes sense. So enriching really in the sense also putting analysis results back into the data set to do some other types of analysis afterwards. Often you use different techniques on the same data, so it's kind of a cycle.
Indeed.
Yeah. Okay. So I think that's pretty clear category, enriching, right? So I feel we have covered that. So should we go to the next one?
Yeah.
Okay, let's pick integration. How do you define integration?
Differ from the enriching. We define integration as it's not using the information within the log, but it's actually taking external data sources to be integrated within the log. So you are joining, for example, other tables, other data information, which was originally not in the log, and now you are joining them using, for example, foreign key references to be able to link it to cases or to events, such that you can add those information to your log.
Okay, so the difference to enriching is that you're not deriving it out of the very same data, but that you are getting external data that you're integrating into the current data set. So you're putting two or more data sets together.
Yes.
Okay. Yes, and for that, so here one of the examples we wanted to show is from one of your master students. So you had a master student. We will also link to his thesis, where he also looked at examples, because also with data integration there can be very different types of integration. I thought that was a very clear way of showing it. So this is an example where instances are integrated. So what does this mean here?
So here we have, for example, 3 cases coming out of, for example, let's say existed in your event data you extracted in the event log you have so far on the left-hand side. And then there's other 3 cases which was extracted, could be from a new system, which you also want to integrate this into your event data. And merging these 3 instances with all 3 instances, you have collected 6 cases. So we have here 6 patients, each of them having a different event activity executed for them.
Yes, so they're basically all copied below each other, right? Or so it's,
yes,
they're
a
all
union
merged.
of the instances. Yes. Yeah. So we had a case before, like we extract some information from an organization, and after some time, the organization decided to switch to a new system. And now we need to extract new data from that system, and we have now two collections of cases where we need to merge them together. And this is a very typical case of log integration, and indeed on the lower level integrating cases, instances.
Yes. Yeah, exactly. So that even simpler maybe would be if you just do a certain analysis every month. You get a new data set for the new month, and you want to concatenate it to the remaining data that you already have to analyze everything together. So you would need to copy that. Okay, so this is one way, but the thing is here, when you're integrating data sets, there's very different ways to integrate them. So you have to look at what's the relation between the two. And just to give another example, here is one that looks similar, but is actually, if you're looking closely at the content, it's a little bit different because it's not integrating instances, but integrating attributes. Can you explain what's the difference here?
Yes. So another low-level category integration could be we are not integrating or taking the union of cases. We're actually joining external data sources to the current event data to add additional attributes. In this case, we had 3 patients, each of them an activity executed. On the other hand, we have another table extracted where it says who is the doctor performed this event for this case, for this activity. Now, if you join the 2 tables using the ID and the activity, you can see that which doctor performed this activity for which patient. So in the resulting table, you see that we added the doctor to the original log. And this gives us then information about which resource performed this task, adding an additional attribute to your log that will enable additional analysis.
Yeah, so here additional columns are created for those existing cases, but there's still 3 cases with more information.
Exactly.
From this integrate. It's also interesting how this merging then happens, right? If you think about it, here you have an ID. I mean, if it's an event ID, it's clear that these are the same events and that they belong together. But if it would be, for example, just the case ID, the activity name, and the date or timestamp, then there could be situations where it's maybe not clear which belongs to which. So.
Yes, so that's why we also distinguish the integration from the enriching, because when you integrate external sources, you always need to think about the how you join the external sources to your current data. You need to find correct keys to join, making sure it's not an invalid link between the attribute you're joined to the original data.
Yeah, exactly. And these are just 2 examples, but there could be much more complicated kind of more data sources, but also more complicated relationships to integrate. And sometimes you can even make choices, right? I think that's something that comes to mind, especially when you have many-to-many relationships. If you want to create an event log from that, often you have to decide which view you want to take on the data, depending on the analysis you want to do, and maybe even create multiple versions by integrating it differently.
Yes, definitely. And you will come to the one of the database where you can do left join, right join, outer join to decide which case or which perspective you take.
Yeah. So that's a whole area in itself. So I think that's also pretty clear. So I think as a category, I would say we have covered that. So let's go to the next one. The next one we pick is filtering. So Xixi, what is filtering?
Filtering means, let's say, removing information from your event data, event log, such that those that you don't want to use for your analysis.
Okay, so filtering. So what could you filter, for example?
You could filter cases. You can filter, incomplete cases. You can filter irrelevant. data, you can filter noisy data, you can filter incorrect data. We have a list of different information you can filter, or the tasks that we found out in the case in the systematic literature review, what people focus on to filter out.
Okay, so this brings us to a very interesting discussion then. What's the difference between noise and outliers? So outliers are something that seems a little bit related, but it's not the same thing. How would you distinguish noise and outliers?
Yes, we have this discussion before, and people have asked me before that too. So what we found out is noise is the definition came from, for example, the signal field. And noise is something that's really there. It's not necessarily a data quality issue. It's there in the background. So you, from the signal field, for example, you have recorded this unintentionally, but it's irrelevant for example, what you really focus on recording or what you're really focusing on analyzing. However, the existence of those noise actually abstracts from you doing your analysis. So when it's abstracting you from deriving your results or performing your analysis, you want this to be removed, and therefore we think filtering noises is a category which can be, which is a separate category.
Yeah, I like the definition that you give because it's more precise, at least more precise than what it started out with. So that was one of the things I always often had discussions about, like noise, because especially when the whole process mining field started, they were from the beginning, researchers were already trying to deal with situations where the data is not as clean, where you just have the perfect workflow data to rediscover, right? So back then already, I think, came from Ton a lot because he had this machine learning background. He was introducing noise in his heuristics miner experiments to make sure that the heuristics miner could still discover the essence of the process despite levels of noise. But what is then noise? So in the end, it was often something like where events were the other way around or something was missing, but that's something that can be there for very different reasons, right? It could be there because of data quality problems or because someone skipped a step. So all of these would be situations where in your definition now, which is more narrow, it would be not noise, because noise is not data quality in the sense that's didn't happen, that it's wrong, but it's something that really happened in the process. But it's still something that's undesirable.
Yes, specifically for your analysis.
For the analysis. So you want to remove it. Generally, you want to remove noise. And we discussed it before, and we found that one example fits the category quite well from what we see in practice. And I brought this here as a last slide to show you, is what we call the spider activities.
Yes.
So spider activities is something that you also find in the process mining book when we talk about the simplification strategies. One of them is removing spider activities, because actually they're really getting into the way of your analysis. And it fits your definition very nicely because it's something that's really there. So for example, this is a consumer electronics refund process where people have a broken device that they return to the electronics manufacturer and they expect to get their money back. But in this whole process, there's certain steps that happen a lot. For example, send email, comment issues. So the employee makes a comment in the case or sends in communication to the customer. So this happens throughout the whole process in different stages, at the beginning, in the middle, at the end. So it does not add any information about the progress of the process or the flow of the process, because it can happen anywhere. So, and it actually happens a lot, but it's something that happens in reality. And at the same time, it's almost useless. So it doesn't tell us anything. So this would be, a noise, an example for noise where you just want to remove these activities. And to do this, how to do that, that's actually quite easy. I can maybe just show you. So here, it's not the same process with still this noise in there. But if there were kind of noise activities, you would just go to the activity, so add a filter and then an attribute filter. And there, basically, you would deselect all the noise activities that were there. So I could just choose, the email, the comment, the ones that I don't want to see, and then it's like removing the rows from the Excel sheet which belong to this type of event. So,
yes.
Yeah, so that's noise. Okay, so yes. I feel we are clear on noise.
Yeah, so another example could be the lab test, which is constantly done in a hospital, or a consultation, which is also, if you look at the hospital event log, you will see that happening everywhere. Yeah. So this is a very clear spider activity indeed.
I'm wondering, because you mentioned this hospital example at the beginning in this case study that triggered this kind of research interest for, was that also something like lab tests or consultations that you removed?
So it's, I think, the consultation. In that case, it's very interesting, actually. It will also link to the fact that there's noise. You can have different ways handling that. You can filter away. And in that case, we actually decide to enrich the noise with useful information such that it become more clear, or it's removing the noise, but then making it more obvious where it happened.
Yeah, like consultation about X or...
Exactly. Mm-hmm. So consultation before the surgery, consultation after the surgery, consultation for specific lab test results, consultation with criminologist, where they have a specific advice over a certain condition. So it was really, we made 5 different versions of consultation, and then remove the rest to show that, okay, these are different stages that the patient goes through, and those are different consultation the patient have performed, and we can then clearly see which consultation, for example, the patient missed.
Yeah. So making consultation before surgery, consultation after surgery, would that be enriching then?
Yes.
Okay.
Yes.
Okay, thank you. So outliers then. How would you define outliers?
Before, I would love to make a disclaimer. We're not claiming this is a D taxonomy or D classification of preprocessing tasks. We did a literature study and we found these categories being mentioned very frequently in the case study that have been done. And therefore, we have derived from that, synthesized from that results, those different categories. So yes, coming back from the outlier, the outlier differs from the noise in the sense that outlier came from the statistic field, and you could do, for example, certain tests to check whether an instance follows a distribution or not, and when it's not following a distribution, or when it's really outside of the normal distribution, then you can classify this as outlier. So it's, again, something that's really happened. It's not necessarily positive or negative, so it could be positive or negative to the process. It can be relevant or not, depending on your analysis. If you are really want to analyze those outliers, so it could be relevant and you don't want them to be removed. However, if you are focusing on something else and you just want to derive the normal or the majority distribution for the majority cases, then you might want to consider removing outlier.
Yeah. Okay. So that's, I think that's a good distinction. So whereas noise is something that you usually would want to remove, outliers in a sense are neutral. So they're really different from the rest of the process. And sometimes you want to focus on the exceptional behavior or those outliers, and sometimes you want to remove them to get an overview of the more general process.
Yeah.
And so the way you do this is then also through the regular tools, right? So for example, if we're looking at the statistics, at the case duration, for example, case duration statistics, then we could see maybe a very few that are taking very long, for example, or
yes.
I think here with the purchasing process, maybe can see it a little bit more. So yeah, we could say, well, these are outliers, but actually because it's not just a few, but it's actually 15% or so, which are taking very long here. Maybe 15% is not an outlier anymore, right? So you could argue, what would you say if you had to give a percentage? How rare would it need to be to count as an outlier? 15%, maybe not.
I will go digger into my statistics book and then check, because it will. I think the normal distribution, if you fall out of the 95%, you can be considered maybe an outlier. And I think if you, so in Python, you can create a box plot, and then they will automatically give you some outlier classification.
Yes. Yeah. Okay. So there are statistical methods definitely for distributions and something you can detect.
Yes.
Outliers. So
yes.
So that's really going into that direction.
Yeah.
Now maybe. So I think that's a point where we can draw back the circle to data quality problems. So outliers can be also a sign of data quality, but they don't have to be. So do you then include data quality outliers here, or do we exclude them? How?
I would actually, in my definition, or as far as I understood from the definitions used, the outlier is actually less likely a data quality issue. I think it's really something that has happened and apparently deviating from the majority so much that it became an outlier. In that sense, I think maybe a data quality issue could have caused it, that certain things become an outlier. But maybe I would call, if it's caused by data quality issues, call it incorrect data instances. And it manifested itself as outlier and appeared from the statistical test. However, I think from our field too, like we call, sometimes we call non-conforming cases as outliers. And in that sense, I would say it's really event or cases that has happened or recorded correctly, and yet it doesn't follow the majority distribution.
Yes, yeah, that makes sense. Yes, so in terms of data quality, mostly you would limit the term outlier to non-data quality problems, because if it's a data quality issue, then that's an incorrect field. For example, if the timestamp was incorrectly recorded, actually the timestamp that's recorded is different from when it really happened.
Good one. Yes.
Yeah, so that would be, and then it's maybe a year like 2099 or something, so that's not possible. So it would appear as an outlier, but actually if it's a data quality problem, it would be in that category.
Yes, it will appear and manifest itself indeed as an outlier. Like if people forgot to enter the start date and the default starting date is 1900, and then you have cases which indeed immediately show up in your statistical tests, and that it took like more than 100 years. And that will be very clear an outlier according to the statistical test. However, if you look at it, it's actually a data quality issue indeed.
Yeah. Yes. Yeah. And they, of course, need to be cleaned and removed and fixed.
Yes.
Yeah, exactly. So I think that's what we are talking about, filtering. So filtering, just to recap, that is about leaving out information. So the question is, what can you leave out and why? And you mentioned it can be activities, cases, events, variants. So on every level, you can leave out things. And you can do this with the filters, for example, in Disco. So you call it filtering as leaving out. But then we got into this discussion, like what do you leave out when, and what is noise and what is outliers. Noise usually you want to filter away. Outliers depends on the purpose of your analysis, if you want to focus on them, keep them, or remove them.
Yes. Yeah, I think in our taxonomy, we had the different entities or element in the data orthogonal to the low-level categories. So we define indeed, for example, irrelevant, incomplete, infrequent, incorrect. Those are let's say R categories, and you can actually remove, for example, irrelevant cases, irrelevant event, irrelevant attribute. So we didn't dive into that level.
Yes, and in the papers you give examples also for that. So that's we will point to that for those of you who want to dive deeper and see some concrete examples for those subcategories which we are not discussing here in detail.
Yeah.
So then I would suggest let's go to the next category. So the next category is log transformation. What is transformation?
Log transformation is an operation which takes a log and then you produces a log where either you replace some element of that was in the original log, or you transform the format of the log, for example.
Okay, so you're not leaving something out, but you're changing something.
You are changing something, indeed.
Okay.
And you're not just adding, which if you're only adding, that will be a log enrichment, but you're really changing it. For example, replacing an old attribute with the new values, or if you had within certain attribute, a certain value you didn't want to be named, for example, none, you can transform it into another value, for example, -1. For representing no values.
Okay, instead of 0 having a -1, for example. Yes.
Yeah.
Okay, so that would be. Have you other examples for transformations?
Yes, we have. For example, if you have a numerical attribute, you want it to be transformed into a categorical variable, and you replace the categorical values, replace the numerical values with the categorical values. For example, if you're requesting a loan amount, and instead of using the actual loan amounts, you just want to know low, high, or medium, you can replace that number with that value.
Yes, I mean normally if you kind of add information like this, one of the recommendations we would usually give is to keep the previous data, right? So you're not throwing away. For example, if you have kind of an amount and you want to have this categorization low, medium, high, you would keep still the amount, but you would like to add an additional column with this kind of low, medium, high.
Yes. So,
but it's hard for me to see why is that not enriching, because you derive this category low, medium, high directly from the data itself. Very similar to what we discussed before.
Yeah, I think if you kept the new attribute and you use it for it's necessary for the analysis, I would call indeed enriching. But if you replace the old one, because also, to be honest, it came from, for example, the machine learning transformation came from machine learning field, where you have to really transform the categorical to the numerical or other way around, because the algorithm cannot handle such a value. Let's say you actually want to use the loan amount as activities labels. And therefore, you cannot use the numerical because it could be too many values to be shown in the process map. And now you really want to replace that with the new categorical values. So you have a limit number of values you will show, and that becomes, for example, the value that you will use. In certain algorithms, they cannot handle those hidden attributes. They're then removed from the data. And in the process mining, we could still always hidden them as event attribute, which is unique how we store our data. But for other, for example, some algorithms, when they cannot handle such a categorical variables, so let's say, for example, the neural networks, you will need to remove those to be able to still use the algorithm.
Yeah, so then that would be to really transform the
indeed.
current data set into kind of a new version.
Indeed.
That brings to mind one of the things that we discussed discussed before about this is also you mentioned, I think, that changing what the case or activity is, like you just mentioned, maybe making this the amount part of the activity name wouldn't be possible if it's a numeric attribute. So that's why you make it into categories. But then also changing actually what you see as the activity or what you see as the case. And that's so interesting, because there I noticed how the philosophy of the tool and the way of working also reflects your thinking. So for me, so if we go back to Disco here, for example, here we have the purchasing process, right? But when we go back to the import screen, in the way how we import the data, we determine like what the case ID, what the activity name is. So for example, if we say, well, we are not making the activity anymore, but we are taking this organizational view by making the role the activity. So then, yeah, it's for me, it's related to importing the data with this perspective, but that's because that's how Disco works, right? If you're thinking in terms of PROM, for example, where you have an MXML or XES data set, yes, the configuration is in the file. So if you want to change it, you have to transform the file to change that attribute.
Exactly. Yes. So especially some like if this import configuration is not supported, you indeed need to transform that attribute such that it appears as activity in the process maps or process discovery algorithms. Yes.
Yeah, so it's interesting, like the bounds, like what we are doing inside or outside of Process Mining tool changes also depending on how you're working, right? And which kind of tool.
And now you mentioned another very interesting example of transformation, which was actually mentioned a lot by a lot of papers that did the case study, is the transformation between different log formats. So we could have thinking as CSV transform into XES is a log transformation.
So but exporting here as an XES or MXML would be also a transformation.
Exactly, yes. And recently we have also, the field has also provided JSON option. So transforming from XES to JSON would also be a log transformation.
Yeah, yes. Yeah, another example I think that we came up with was preparing a free text field. So it's in the same way, like a numerical loan amount would not be suitable to be an activity name if you have not a real activity name, but a free text field where, for example, the call center employee types in some notes for each call they're having, then this will be very unstructured and unique almost for every entry. So you are not having a generalized activity name, and you need to do something, pre-process the data by maybe doing text mining or some other type of categorization of this free text data. So that will be part of log transformation.
Indeed. Yeah. Very nice example.
Yeah, so it's a little bit blurring then where the lines, like if you're thinking in these categories, so that's also like, is the data suitable? So at the very beginning, when you're preparing your data, you're checking the requirements for process mining. So we have a data suitability checklist where you have some instructions how you can check that you have the correct case ID, activity name, timestamp requirements, but also some others. And actually having a non-free text activity is one of that there. But I think it's clear it belongs into the pre-processing. That's what you need to do then to make it suitable.
Yes.
So let's see, did we have any other examples for log transformations?
I actually see a chat.
Yes, okay, can you read it?
Conversation to level low, medium, high is data information reduction. Thus a transformation that should be avoided.
Okay, reduction. Okay, that's a good way. We are coming to reduction because reduction is the next category. So let's discuss if this fits into reduction. Xixi, log reduction is the next category.
Yes, we consider log reduction as not just simple filtering, but other techniques which trying to either reduce the number of instances or the number of attributes in your log. For example, sampling will be very
sampling, yes.
A nice way to show that log reduction.
Why would you do sampling? Maybe can you give an example?
So sampling can be done if the log is too big to be handled by certain tools, let's say. For example, if you don't have the full version of this code, you might need to sample the log to be able to create a representative process map of your event log for your process. Other ones could be that you want to still follow certain distribution and then sample that based on that distribution of your log to do repetitive tests or other tasks, let's say.
Yeah. Or maybe another one. So we often see, like, when people do customer journey analysis by taking clickstream data from websites. If you're on a major e-commerce website, that can be millions, billions, I don't know, events per day. I don't know, too much to look at 3 months of data in its entirety. So you have to do some kind of sampling to get, especially if you want to look at long-term processes for kind of customer interactions. Over a longer period with this type of process.
Yeah, so it's a very known actually task to reduce the number of instances in the log such that you can enable certain analysis that might be computationally very expensive.
Yeah. So what do you say about the comment? Should the changing from numeric to categorical, should that count as a reduction, or you still think it's a transformation?
So what they say, information reduction, which could definitely is reducing the information. Yeah. However, we considered or we placed that under the transformation because I would say the reduction is really, log reduction focuses on pre-process the log such way that it reduces the information for the analysis, and transformation is transforming the value for the analysis. So if it's just to if you don't do this transformation, so the analysis could not be done or not be done as good as after the transformation. And transformation comes, for example, let's say using decision tree for finding your root cause, why certain things happen. And it could be the case that certain algorithm doesn't handle the numerical variables so well. Therefore, we transform the data using the categorical variable. Yeah. So in outside of our taxonomy, it could be information reducing the information. However, within our taxonomy, we classify this as transformation.
Yeah, but maybe because it's information reduction, so if it's not required by the technique, normally you would keep the original field and just create a new one with this more categorical information, and then that would be enriching.
That would be enriching. Yes.
No information would be lost.
No, then you can keep all the information in one.
Yes, exactly. Another example that we discussed before, so what you said would be log reduction. I can show maybe, so it's the 2012 BPI challenge, right? Let me see. Okay, so the 2012, because the 2012 BPI challenge has actually 3 different sub-processes. So everything all together is shown in this process map, but actually these are 3 sub-processes in one picture. So one way to apply log reduction would be, in this case, to separate these different types, and I can show you how to do that. So in this case, we would use the attribute filter, for example, here starting from maybe the applications. So all the activities with A underscore are related to the application, handling of the application. So we would separate that and say this is applications. So it's much smaller, much more manageable piece. So now we go back and we would again start from the empty list and say the offers. So that's everything related to dealing with the offer that's being made. It's a loan application process, I think. Offers. And then again, it's just this sub-process. And then we can take the last one. And I think W stands for workflow, right? I think these are all the workflow tasks. So let's call it workflow. Yeah, and that's the bigger piece. But yeah, so to me, why is this not filtering? We are leaving out a sub-process, not just an event or a case or an activity. But we could make the case, we're leaving out actually certain types of activities.
Good question. So the log reduction focuses on that you have the three, so you're reducing to sublogs such that you still have the view on different sublogs. And it didn't fall into the filtering because it was, as we said, filtering could be a task and with certain aim of it. For example, we have labeled filter incorrect, filter irrelevant. Those are, for example, a task level. However, you could have filtering as a technique, which could serve different tasks or purposes. In this case, you are using the filtering technique to reduce the log in such a way that it gets divided into sublogs. And therefore, we think this at the task level, so it focuses on, let's say, reducing the logs into sublogs. But you can use definitely the filtering techniques to help you realize those tasks.
Yeah. Were these the two that you pulled out, that were one and that you made separate, like filtering and reduction?
Yes, exactly.
Okay. Yeah. I think for sampling, it's clear. Somehow sampling is a different thing. Yeah. So this type of sub-process seems very similar to me to the filtering. So I'm not sure.
Yeah, so the reason is that reducing to sublogs, it doesn't just have to be filtering. You could actually have other techniques helps you doing that. For example, clustering or interviewing expert. It could be even not like disjoint subclusters. So there's a lot of different complexity there. And in general, we see case studies mention this as reducing or dividing logs into sublogs. And they are unclear about, for example, what exactly technique they used. Mm-hmm. And therefore, we think this is an important task which have been mentioned, but not very well, let's say, untangled in the sense that it could be actually focusing or trying to achieve different purposes. Mm-hmm. Yeah. I hope this is very clear. So our tasks are really focusing on the high level that you're trying to do and we're trying to achieve, and not really at the level of which technique you are using and how you exactly realize that yet.
Yeah, that's another distinction, right? That's also something I think that, we talked about that too. Maybe it's now a good time to say that, because you have the tasks, but then you also have techniques and you have methods.
Yes, right? We have. So, yeah, exactly. So for us, tasks is rather high level with a certain purpose that you want to realize, whereas you could have indeed different methods that helps you realizing that, and different techniques and different tools. And I think if we really want to define, the methods will be you have the same input, but for example, I could use Disco to help me filtering the incomplete cases by specifying a certain endpoint. If it doesn't have that endpoint, you can filter away. However, I could also say if the cases are longer than that, that's my complete cases. If it's shorter than 1 day, then I don't look at those cases. So those are two different methods with both focusing on filtering away the incomplete cases but have different results. You could also have the same methods, which, for example, using the end activity filtering, but using different techniques or tools. For example, I can use Disco to filtering or specify. I can also use Python, but they will derive the same output.
Yes.
Yeah.
Yeah, that's a good distinction. So that's basically the hierarchy of tasks, methods, and then tools or techniques, how to do it specifically. Okay, so then reduction. The last category is abstraction. So how would you then explain abstraction?
Log abstraction also differs from log reduction and filtering. Is trying to not remove but hide information. However, it will still indeed keep such information by, for example, adding a representative notes or concept to it. And it can be easily retrieved when the user asks for it. And there's a concept in actually information visualization, which is known as the details on demand. So it's hidden away, but if the user asks for it, it will easily pop up or being retrieved. And we consider that as log abstraction. So you're abstracting away a certain information. The user knows you abstracted away from it, and they can ask for it if they want to.
Yeah. Yeah, I think that really resonates for me in the sense that it relates to our explorative analysis stage if we are looking at the 12-step methodology that we use for process mining. So there, before you go into the targeted analysis, there's a previous stage which we call explorative analysis, where after data cleaning, data validation, so that has already happened, but before you go into the analysis for answering concrete questions, you are exploring the data and you're looking at it on different levels. For example, and then it's one of the things that's very good to do is to take a bird's eye view on the process, look at it on a very high level view, for example, or to look at the main process.
Exactly.
By focusing on the main variants. So these would be all simplification strategies that can be then applied.
Yes.
And so I'm not going to show much more here because the explorative analysis stage is actually the topic of our next Process Mining Café coming up in a month. So we will do a lot about exactly these kind of things there. So yes, but to me it's still, so it's clear, I think, and I relate to this as an important task. It's one could say, or is it really pre-processing because you're already almost in the analysis, but it's definitely before the final analysis, right? That you're changing the data, and because in Disco it's also integrated, it feels to me like part of the analysis, but I can see why it's part of the pre-processing phase. But as a separate category from between filtering and log abstraction, is it not also, again, it seems related. So how do you make the distinction between these two? Maybe you can say again.
I think the filtering, you really remove the information for the abstraction. So actually, Christian works on the fuzzy miner, and I think that's a great example where the lower level activities could be clustered into a higher level activity.
Oh, yeah.
So you're hiding away the low level activities, but you still kept a high level activity that represents all the information that you had hidden away. And that's, for me, typical log abstraction, which also was, for example, where Boss, Franz Jost, and his co-authors have made an entire taxonomy on event abstraction. You can do that in different ways. You can map multiple lower level activity to single high level activity, or map it to multiple different high level activities. You can doing one-to-one relationship. You can do many-to-one. You could say there's non-overlapping or other way. So they have proposed different categories, and therefore in the paper we published, we also didn't dive deeper because there have been mentioned different ways you can categorize. Especially,
you point to them for
yes,
the
we
details.
pointed to them, but in that case, like that's for me, you are hiding away information and user knows about it. It's different than when you filter away and you show the end user, for example, your process map, the filter, the user might know what you filtered. So it will not see in the process map itself that you have filtered. So that's I think for me the key difference. Like there's certain information in the results that still represent something has been hidden away or abstracted from.
Yeah, for me it also makes sense, like you mentioned, that there are different ways to create these abstractions and to aggregate, and so I can see that there's a lot of different ways to do that. So
we definitely have this discussion. Yes, people might see that filtering abstraction is also filtering because you remove the information. For us, or for me, you are still not completely filtered away. You have some representative information or entity left that you can represent, that you have hidden some information from the user.
I think for me, so if I look at your categories, the filtering category is really one that I was struggling a little bit with, just because filtering is such a big concept for us, and it's part of Disco, how you do the analysis. Every analysis question that you're answering, you're basically creating a combination of filters that you stack on top of each other to answer that specific analysis question. And of course, you can use the very same filters to clean data quality problems. So you use the filters for different purposes. But from your explanation, I can see the categorization you have made.
Yes, I think if you filter away and you create information that you have filtered away, for example, these cases, for example, in the process map or in your log, I think that would, for me, be abstraction. Let's say you have hidden 1,000 cases and you have created information. Okay, be aware there's 1,000 cases hidden. That could be an abstraction because there's this information still represented. It's difficult to see how it's hidden away cases, but for activities, that's very clear for me, that you can have a high-level activity representing all the low-level activity you have hidden away. For cases, you could see like the path maybe is completely hidden, but you draw a special arc, say, okay, we have this, it's completely not following the current path map, but those 1,000 cases, it's now not visualized but hidden. And if you click on that, it will show again all the 1,000 cases variants going through the process map. That will be cases abstraction. Yes.
Yeah. Very good. Okay, so now we talked about all of these categories separately, and we tried to give you an example for each of them. But as a last point, right, we wanted to mention also that it's not necessarily the case that you use those in isolation, but often you have actually combinations or sequences of certain pre-processing tasks that will occur in practice. For example, first removing incomplete cases, and then afterwards maybe focusing on the main flow of the process, or there are certain common sequences, and that's also something that you're interested in your research, right?
Yes. After we have found this taxonomy from the literature study, we synthesized this taxonomy. We did a follow-up study, so we had a very nice master student who helped us interviewing practitioners, how they used this taxonomy. We also annotated for each case we have found the steps, how they perform their pre-processing tasks. And from that, you can actually create an event log and use process mining to analyze this log. And we found out that, for example, filtering irrelevant data and then filtering incomplete cases, and then create a process map, for example, is very frequent variant how people perform their pre-processing tasks.
Yeah, and actually that's a very nice and interesting link to. We can put a pointer also in the show notes to the Process Mining Café that we did with Francesca and Penina and Barbara about the process of process mining. So they're also looking exactly at these kind of sequences and the analysis workflows that people have. So I have to look back at that, but I imagine pre-processing is also a big part of that.
Yes, so what we also found out is it's a very flourish model from the case study we have reviewed. And there's, other than this frequent pattern, there's very few frequent patterns, and people tend to really also do it iteratively, and therefore do some filtering and then go into the analysis and then do some filtering again and do the analysis. So it's a process that definitely still can be supported, streamlined, and more structured. Yes.
Yeah, maybe we can make some checklists or something for certain things you can do on the data pre-processing.
Yes, definitely. Yes. Yeah, we were thinking using this as a reporting template, which you can say, I did this, I did this, I did this in this order. And it might help to, we hope this really helps improve the traceability and the more reproducibility of pre-processing.
Yeah, and ultimately maybe coming back to the beginning, the story that you told at the beginning, if you do this right, you can increase what you can do with the data, right? You can get more useful insights out of the data because, you can do more.
Yes, we can. You can showcase what can be done. For example, especially from the inventory, you can show that this is possible, and this is, let's say, creating a creative template people can just use to also really get more value indeed from the data and enable additional analysis.
Great. So let's do that. So we keep in touch about that. We let you all know if there's any news coming out of this stream of research, which I really like a lot because it's very much also looking at all these practical questions in process mining, which are really important. So I'm really happy to see all your work, and we'll follow closely what you and your colleagues are doing.
Thank you so much. We're very happy. Just really a disclaimer, because we also got a lot of discussion from also our colleagues and from our fellow researchers. It's one way to categorize the pre-processing step, and we synthesize this from the tasks, low-level tasks we have found in the case study, and therefore we propose this 6 high-level, so categorizes the low-level tasks into these high-level tasks. We have also seen that there's other ones. For example, I have mentioned Dirk's work. I have mentioned, for example, there's another work where they propose different type of taxonomy simply based on the techniques instead of really on the high-level tasks, which might be also categorizing the pre-processing in a very different perspective. So definitely a lot more to be done here. And I totally agree. And from someone who working on this, I think this is could be very valuable for indeed enabling multiple ways to get more value out of the data.
Yes. Okay, and are you looking for feedback from people? Are you doing more studies, or are people who want to help, can they contact you? Or?
Yes, very much, very love to. We are working on extending this work. We want to really also, in the future, maybe create a platform which provides these tasks and support for each of those tasks. For example, showing different techniques or code snippet. We are looking for example, end users, practitioners who are interested in. So if you are interested in participating, or if you have feedback on this, don't hesitate to drop an email, contact me. We will love to hear from you.
Excellent. So nice that you were here, Xixi. I very much enjoyed the discussion. Thank you for taking the time.
Thank you for having me here. Thank you for the invitation. I also really love the discussions we had.
Great. All right. Thank you all for watching. We really, liked to spend time with you here today. We will see you again next month. As I mentioned already, the topic will be explorative analysis. And there we will dive deeper into this pre-analysis exploration and show you, based on examples, exactly how to do this and give you some instructions and guidelines. Okay, thanks again. Thanks, Xixi. Thanks all of you. See you next time. Bye.
Thank you. Bye.